A 220 volts 15 kVA 1000 rpm shunt motor with armature resistance 0.25 and a line current is 68 amps and field current is 2.2 amps. The change he is asking to find change in field flux required to obtain the speed of 1600 rpm while drawing a line current of 52.8 amps and field current is 1.8. Now he mentioned that it is a shunt motor. So let's draw the shunt circuit. This is the armature circuit. Brushes is also available, and this is field circuit. Here this is supply source IL, IA, this is IF. This is the supply source. Now by applying KCL at this node, let's say it is X, by applying KCL at node X, it is entering current is IL and IA and IF are leaving currents. So IA plus IF, sum of entering currents is equal to sum of leaving currents. Now we want IA, so IA is equal to IL minus IF. In case 1, he gave IL1 is equal to 68, IF1 is equal to 2.2 amps and VT is equal to 220, speed n is equal to 1000 rpm, RA is equal to 0.25. Now to calculate back EMF, EB is equal to, we want to calculate back EMF, EB is equal to VT minus IA RA. In this we want IA. For that IA is equal to IL1 minus IF2. IL1 is 68 minus IF2 is 2.2, which is 65.8. Now find EB. EB is equal to 220 volts because VT is constant minus 65.8 we got, and RA is 0.25 he gave, which is 203.5 volts. Now let's see the second case. In second case, flux is modified. N2 is given as 1600 rpm. N2 is given as 1600 rpm. IL2 is equal to 52.8 and IF2 is equal to 1.8. Now let's find IA2 is equal to IL2 minus IF2, which is 52.8 minus 1.8, 51 amps. EB is equal to VT minus IA2 RA, which is 220 minus, we got 51 into RA is 0.25, which is 207.25. Now we have another formula to calculate the EB, that is EB is equal to Ka pi omega. Here Ka is constant, so EB directly proportional to pi and n. Omega we take it as speed n. So EB1 by EB2 is equal to pi 1 by pi 2 into n1 by n2. Here EB1 we got 203.55. EB2 we got 207.25. Pi 1 by pi 2. Previously speed is 1000 rpm. N2 is 1600 rpm. Now let's cross multiply 207.25 into 1000 by 1600 into 203.55 is equal to 0.636351, which is pi2 is equal to 0.636351 we got. Here we got 0.636351. Now find the percentage change in flux is equal to pi2 minus pi1 by pi1 into 100, which is 0.6363 minus 1 by 1 into 100. Here's minus 36.36% we got. Here negative sign indicates decreases. Here he gave IF is at first case it is 2.2 amps and second case it is 1.8 amps, and we also use in DC machines flux is directly proportional to field current, so we can directly use this and solve. We got minus 1.18 we will get. That is also available in options, but that is wrong, because flux is directly proportional to field current only when the practical magnetization curve is linear. Here he didn't give it is linear or non-linear, we don't know, so we can't take that directly. So we solve this problem by using this process.